This will be a brief video on how to use AutoR1 and what changes it implements in a standard R1 project. The first step is to download the program. A link will be provided in the description below the video. After downloading, the next step is to open our project in R1 and let the default views and groups be created. To do this, we select Yes when this dialog box is shown on opening the program. R1 will now create default views and groups for all sources. These are required for AutoR1 to operate correctly. The next step is to save and close the project. We will now copy the project into the AutoR1 folder we downloaded earlier. Here we rename the project to r1.dbpr. Your project is now ready to be modified by AutoR1. Next, we run the relevant start file for the operating system being used. Here I am selecting the start-macOS file. If you're on macOS, you may need to right-click and select Open to avoid any system dialogues about the program being unsigned. Now a terminal window will display with the message Finish generating views, controls, and groups. If all went well, you'll now find a new file in the folder called r1_auto.dbpr. This file is the new modified project and can now be opened in R1. First, we will look at the master page. Here you can quickly access important settings for all source groups, as well as monitor the status of all devices on the network and configure the fallback system if required. The title of each group can be selected to view its default R1 view. You can return using the button in the top left. The default EQ views can also be reached using their buttons located here. GSL and KSL systems are provided with the new CPL functionality, while all other relevant systems have the original CPL implementation shown. To use the new THC function for array processing, select an AP slot on each AP-enabled source, each with the same temperature and humidity settings rendered in ArrayCalc. After doing this, the one single THC display can now be used to control the values of all array processing sources at once. Finally, there is the meter view. If we zoom out, we can see a view of every channel in the PA. Source groups are split into their discrete left, right, sub, and top groups. Each group has a configuration frame allowing access to its AES sync status as well as its fallback settings. This allows for very fast fallback configuration for each source group. Those using DS10 network bridges will also be able to access the DS data of every channel.